Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
All right, question 8 in chapter 32 states that the biologically equivalent dose for a typical chest x-ray is 2.5 times 10 to the negative 2 rem, or 25 millirem. The mass of the exposed tissue is 21 kilograms, and it absorbs 6.2 times 10 to the negative 3 joules of energy, or 6.2 millijoules. What is the relative biological effectiveness, or RBE, for this radiation on this particular type of tissue? Okay, so we're given BED, dose, mass, and we look for RBE. So we can start with just the relationship of the variables or the objects that we know. If the BED is simply RBE over times dose, then the RBE we can represent as the BED over dose. And since we're not told dose, but we're told energy and mass, this dose term can be represented by the energy over mass. So we have Q on our denominator, our energy, multiplied by mass in our numerator. We have all the values that we know. We may need to convert units, but we'll check that out once we put our units in our equation. So we have here dose of, BED of 25 times 10 to the negative 3 rem, multiplied by mass of 21 kilograms. And this is all over the energy of 6.2 times 10 to the negative 3 joules. So here we know we have rem divided by gray, because it's joules per kilogram. So when you get rid of gray, right, and convert it to rads, such that if we divide rem over rads, we'll find the RBE, the typical units we would use for our initial equation. So because we have gray starting on our denominator, we need to multiply that by 1 gray in our numerator. And we know from rem to rad, 1 gray is simply 100 rads. And just to check, our gray knocks out this gray term here, joules over kilograms. Rem over rad does produce a value of RBE, and we find that this RBE value with this equation in these terms is simply 0.85. And there you go.